This assessment asks us to predict the product of the crossed aldol shown on the screen. We note that this reaction uses sodium hydroxide and water and is heated, and so that's going to suggest that we drive the reaction all the way to the elimination product. We're not going to really show the full mechanism of this reaction, but we'll give enough details so we understand how it works. The reaction is going to start by deprotonating the ketone to make this enolate. Right, we'll make that enolate. Notice that our aldehyde has no alpha hydrogen, so we don't have to worry about it forming an enolate itself. And so now that aldehyde will be the electrophile that will react with this enolate. And so this is going to make a new carbon-carbon bond. We'll use our equilibrium arrow to show that. And we'll talk about stereochemistry, but for right now, we'll just draw this. I'll draw in the hydrogens here just to make it clear what bond we formed and broken to give us that product. Now, we have created a new stereocenter, so that attack is going to happen from the front and the back. So this reaction is going to end up producing two diastereomers. We'll show both of those at the end of the reaction. The way the reaction, actually, I take that back. We're not going to form two diastereomers. Stay tuned. Next step, we're going to react with water. Why aren't we going to form two diastereomers? Think about that as we go through. Next step, we protonate. That's going to give us this product, which at this point in the reaction, we would have two diastereomers. But remember, we're heating the reaction. And so we know we're going to eliminate this hydroxyl group in this step. Mechanistically, the way that will happen is hydroxide will come in and remove the proton to make an enolate again. That enolate is this. And that enolate will then collapse down, pushing the pi electrons over to kick out hydroxide so that the final product of this reaction is this. So we had formed a new stereocenter at this carbon, but that is now here, no longer a stereocenter because we've done the elimination. So that idea of showing both diastereomers ended up being unimportant. This is the product of the crossed aldol. The reason, again, just as a reminder, the reason we made that double bond is because we are heating this reaction. We're driving it to eliminate water as the final step.